Okay, so the derivative of a function f at a point x sub 0 is denoted by f prime of x sub 0. That is, f prime of x sub 0 is the limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0 over h, provided this limit exists. Now we have looked at this limit to determine the slope of tangent lines to a curve. Now we're going to revisit a problem from a previous recording. Remember we talked about a rock that fell freely from rest near the surface of the earth. The rock falls at y equals 16 t squared feet during the first t seconds. And we wanted to know exactly what the rock speed was at time equals 1. Now if you will remember, we found some average speeds over time intervals right around 1 second. We looked between 1 second and 2 seconds, and between 1 second and 1.1 second, and we were looking for an approximation. We can use this formula to find the instantaneous speed of this rock at time t equals 1. That would be f prime of 1, which is the limit as h approaches 0 of f of 1 plus h minus f of 1 divided by h. That is the limit as h approaches 0. And if we take f of 1 plus h, we'll plug 1 plus h into 16t squared, so we'll have 16 times 1 plus h squared minus. Then we plug 1 in, 16 times 1 squared, and that'll all be over h. Okay, next we take the limit as h approaches 0, and we simplify the numerator. Remember when you do 1 plus h squared, that you can use the perfect square trinomial formulas, or write 1 plus h times 1 plus h and use full. And that will be 1 plus 2h plus h squared. And of course 1 squared is 1. Now we'll distribute. This is going to be the limit as h approaches 0 of 16 times 1 is 16, 16 times 2h is 32h, 16 times h squared is 16h squared, minus 16 times 1 is 16. And this is all divided by h. Well, this will give us the limit as h approaches 0 of, since we have 16 minus 16, we can cancel those, and we'll be left with 32h plus 16h squared in the numerator and h in the denominator. Now we're still not to a point where we can plug 0 in for h, since our fraction will still be undefined, so we need to continue to simplify. We have the limit as h approaches 0, and in the numerator of our fraction we can factor out an h. h times 32 is 32h, and h times 16h is 16h squared. By doing this, we can then cancel our h's, and we're left with the limit as h approaches 0 of 32 plus 16h. Now we can substitute our 0 in, and we'll have 32 plus 16 times 0. 16 times 0, of course, is 0, so we will have 32 feet per second. If you'll remember back to the example, as we started using time intervals closer and closer to 1, we started to approach 32 feet per second as the instantaneous speed. Now this limit that we have been using can be interpreted in different ways. It's the slope of the graph y equals f of x at a point x equals x of 0. It's the slope of the tangent to the curve y equals f of x at x equals x of 0. It's the rate of change of f of x with respect to x at x equals x of 0, as we saw in our last example. It's also the derivative f prime of x of 0 at a point.